Hello guys and welcome to a new lecture about Python programming. In this lecture we want to study functions. Python supports four main type of functions, each serving a distinct purpose. Built-in functions, functions via imported libraries, user-defined functions, and anonymous functions. So the first one that we are going to try is built-in functions. So these are some predefined functions provided by Python itself, like print, len, type, or sum. We can use them directly without needing to define or importing anything, right? Python comes with a rich set of built-in functions. They do not require importing any modules. These built-in functions are available right out of the box and incredibly versatile. By the end of this tutorial, you will understand how to use these built-in functions from simple tasks to advanced programming techniques. Let's begin with some commonly used built-in functions that every Python programmer should know. We already tried it many times. For example, name is equal to Jones, right? And we can say print is a function, built-in function, right? So we can say print hello and then name, right? So hello will be printed and name is a variable. So the value of the variable will be printed here, right? Also, we can have input function. For example, I say age equals to input, enter your age, right? So in here, this input function asks user to enter something. So when you enter, so this 25 will come here as the age. The next one is a len function, right? So for example, I say message is equal to Python is fun. Then I say what is the length of this message, right? It means the number of characters in this message are 14. Python provides built-in functions to convert between different data types, which is crucial for handling different kinds of data. We can convert, for example, a string to integer. For example, the user input is, for example, 42, 42, right? And I want to convert it as a number. So if I get what is the type of this user input, type of user input is string. I want to convert it, so simply I can say int user input 42. And if I assign this one to a variable, for example, age is equal to user input, and here I can print age, and type of age is integer, right? We can also convert an integer to float. For example, n is equal to 10, and then I can say f number equals to float, for example, n, then I can print it. So the type of n is integer, but type of n underscore n is float. Python also includes several built-in functions for basic math. For example, I want to go for absolute value. If, for example, I say negative number is equal to -7, right? Then I can get the absolute value. So this ABS will give me the absolute value of this number. It's -7, but it will give me 7. I can go for max or mean. For example, I have like n equals to 1, 2, 3, 4, 5, 6, 7, 5, 2, something like this. Then I can say what is the max of n? It's a 45. What is mean of n? It is 1, right? What is sum of these numbers? Sum of n? So 88. It's sum of all numbers in n, right? Then, for example, I can go for round. Suppose I have pi equals to 3.459. So we have here 5 decimal points. So if I round pi, and for example 2, it means I want to have only 2 decimal points. So it will round up it, right? Then we can go for iterable functions. These iterable functions help us manipulate and inspect lists, tuples, and other iterable objects. For example, we have range. Like I say, for example, S is equal to range of 1 to 6. So this S, I can print it. S is 1 to 6, a range of numbers 1 to 6. So it generates number 1 but not including 6 up to 6. It means 5 will be there, 1 2 3 4 5. So if I want to print them one by one, I can say for example I in S, for I in S, print for example I. So you can see 1 2 3 4 5, right? Then for example we have sorted. So for example, we want to sort that one. So n was this one, n was this one. We want to sort it, right? So we go for sorted function, and it will sort 1 2 2 3 3 4 5 5 6 7 45, right? It will sort for us. We can also go for reverse. For example, r is equal to reverse n. Then we can print r. So in here, it will not print it. If you want to print it, we have to print it as a list, right? So you can see here, 5, 5, it's not sorted. It's in the main n, right? The main n. So if you want to go for sorted, we should write here, n underscore s is equal to n sorted. Then we will reverse n underscore s, then here. So you can get the sorted one. In Python, we have built-in functions, including powerful tools for functional programming like map, filter, zip. For example, we have n is equal to 1, 2, 3, 4, right? We want to get a square of this one, so we can go for map. For example, Sn is equal to map lambda x square and n, right? Then we can go for list s underscore n, right? What happened here? This is called as lambda function or anonymous function, right? So it will get every value in n and it make it a square. And map applies the lambda function x square to each item 1 4 9 16. Then we can print them in a list. Also we can go for filter function. For example, I can say events is equal to filter lambda x mod 2 is equal to 0. If it means reminder is equal to 0, it means it is a even number, right? Then if I print them as a list, so list events, right? So 2 and 4. So out of here, 2 and 4 are even. We can also go for zip function. So zip function is used to pair items from multiple iterables. For example, we have names is equal to like A, B, C, and D. And also we have age is equal to, for example, 12, 13, 14, and 15, right? Then we can pair corresponding elements like A12, B13, C14, D15, right? So we go for this one, for example, paired is equal to zip, and in here I can say name and age, right? So then I can print this pair as a list, right? A12, B13, C14, and D15. Previously, I told you that using type, we can go for find out the type of our data in a variable that we have. So the type of this one is zip. Also, using ID function, we can get object's memory address, right? ID of pair is this one, right? It means this is the memory address where this one is added. Also, we can go for dir function to list attributes and methods, right? For example, dir paired, right? So here you can see the list of attributes and methods that we have. This is a list of valid attributes and methods for the object that we have. We can combine built-in functions in real world scenarios. Let's tie it all together with a practical example. For example, we have a scores equal to, for example, 85, 92, then 78, 95, 88, 76. Then we want to calculate the average, right? So average is equal to round, then sum of scores divided by length of scores. And we want to get up to, for example, 2 points, right? Then we can go for average. So absolutely, we have some functions from NumPy and other libraries for average, but if you want to go for built-in functions, we can calculate the average in this way. If we want to go, for example, to find top 3 scores, right? So top scores is equal to sorted scores, and reverse is equal to true, and we want to get out of this list only top 3, right? So then we can print top. 95, 92, and 88 are top. We can categorize scores, for example, pass if it is more than 80. So we can say, for example, pass is equal to list filter. Then we go for lambda function, lambda x if x is greater than 80, and based on what? Based on scores, right? So we can print it pass. So we had one less than 80, it cannot pass. So 85, 92, 95, and 88 can pass. We can also pair scores with student ID. For example, IDs is equal to range 1 len scores plus 1. Students equals to list, then zip function, then we can say IDs and scores, right? Then we can print students. So 1, 85, 2, 92, 3, 78, 4, 95, 5, 88, 6, and 7. The next one is all function. The output of this one is true if all elements in an iterable are true. For example, print all. I can have, for example, true, 1, and for example, hello, right? The output of this one should be hello. This one should be in this brackets. So true. If I change this one to 0, for example, it will be false. If I change this one to false, again, it will be false. Then we have any function. This any function returns true if any of elements is true. Let's copy this one here. And if I say any, right? So it will be true. If I remove this one, for example, remove this one, it will be false. If I change this one to 1, it will be true. It's like this one is like AND, this one is like OR operator. The next one is bin function. Bin function is used to convert decimal numbers to binary, right? So this 1010 is the binary representation of 10. So for 0 we have 0, for 1 we have 1, for 2 we have 10, for 3 we have 11, or you can go for any number. It will give you the binary representation of that one. Then also we have Boolean function. Bool converts a value to Boolean, right? So if you say bool 1, it will give you true. If you say bool 0, it will give you false. So if it is not 0, the rest will be true. Then we have byte array. This returns a byte array object. For example, I can say byte array, a byte array hello, and I say based on UTF-8, right? So it will be byte array of this one. This is byte array object. Then we have bytes. This convert the string to bytes. For example, I say bytes, for example, hello, and in here I say UTF-8, right? It will give you the bytes. Then callable checks if an object is callable, like a function or class. For example, callable, then I say len, right? It's a true. Then we have char, CHR, that converts an ASCII Unicode to a character. For example, CHR of 97 is A. CHR of, for example, 118 is 1 by 4, right? Or for example, 18 is this one. For example, 98 is B, right? 61 is equal sign. 65 is A capital, right? If you want to create a complex number, right, you can go for complex 3 and 4, right? It will give you a complex number. Then if you want to create a dictionary, dict, for example, name is equal to A and age is equal to 20, right? This is a dictionary. Name is equal to A and A. So this is a key, this is a value. Then we have div mode that returns quotient and remainder of a division. Div mode of 10 and 3. It means if you divide 10 by 3, this is the quotient and this is the remainder. This div mode function returns quotient and remainder of a division. Then we have enumerate function. Enumerate adds an index to an iterable. For example, for I and V in enumerate, like I can say A, B, and C, then we can print I and V. 0A, 1B, 2C. Then we have eval function. This eval function evaluates a string as a Python code. Eval 10 plus 5, right? 15. Even though they are string, but they will be treated as integer. Then we have exec. Exec is used to execute a string as Python code. For example, I say exec x is equal to 10, then n print x, right? So it will print it as x. Then we have filter function. It used to filter elements in an iterable based on a function. For example, I say list filter lambda x in such a way that x is greater than 2 and from where? From 1, 2, 3, 4. In this one, this will check if x is greater than 2, then it will be printed. So 3 and 4 will be printed. Then we have float. So this converts to a value to a float point number. For example, I can say float float, even though this is a string, but it will be printed as float. Then we have format. Format a value into a strings, right? Format, I can say 255 and X, right? So FF will be printed. This is hexadecimal format. Then we have frozen set. So frozen set is to create an immutable set. I can say frozen set of, for example, 1, 2, 3, right? So the output will be a frozen set. Hash function returns a hash of an object, right? You know, hash function is used for security purpose. So this is hash conversion of hello in such a way that cannot be guessed. Or we have hexadecimal. This hex is to convert an integer to hexadecimal. So hex of, for example, 16 is 10. Hex of 15 is F, right? In this way, it can work. Then we have iter. Iter function is used to return an iterator. For example, iter, I say 1, 2, 3. So it will return this one. And if I say print next, and let's say this one is equal to, let's bring this one all here, right? So 1. Also, we can convert an integer to octal, right? In base of 8. For example, octal of 255 is this one. For example, octal of 8 is 10, and octal of like 7. Also, we can use OR to convert an integer to ASCII code, 65. You can use power to raise to a power, like for example 2 in power of 3, it will be 8. Okay, so this was, simple introduction about built-in functions. Please practice and feel free to ask me if you have any question by leaving a comment below this video. Thank you for your attention and see you in the next lecture.